All right, so in this video here, we're going to be looking at the review test questions that you were assigned in the review from chapter 5. So I went ahead and wrote those out ahead of time, and we'll look at the review test questions here. So the first question that was assigned from page 217 is question number 14. So on question number 14 here, okay, it has that X is the number of homes sold in a week, and then it gave in the book that probability distribution, and it wants you to find the mean and the standard deviation of that distribution. And so in order to find the mean, we need to think about this as a weighted distribution here. So we want to make sure that we multiply each X value by its probability, okay? And then we're going to add up all of those X times P values here. So the first one's going to be 0 times 0.15 plus 1 times 0.24, and so on and so forth down the line. Now I'm going to go ahead and do this on the 84 calculator, just because I think under the camera it looks a little bit better. You don't have to worry about like screen shining and all that stuff. So I'm going to go ahead and do this. Okay, and so each one I'm multiplying X times its probability here, and I get an average of 2.04. If I want to find the standard deviation, then the equation for that is going to be to take the sum of X squared times P, and we're going to do all of that first, and then you're going to subtract out the mean we just found squared. Okay, and so what that would look like is your first one would be 0 squared times 0.15. Your next term would be 1 squared times 0.24. And we'd keep going down the line until we get to 5 squared here. After all of that, you're then going to take the mean, square it, and subtract it out. And that would find you the variance. Okay, in order to find the standard deviation, we're then going to take the square root of whatever that number is that we get. So here, kind of doing this the long way, I'm going to enter in each one of these. So again, it's X squared times its probability. Okay, now that's just this X squared times P of X sum. I'm going to then subtract out the mean squared, and that finds me again the variance. So the variance of 2.0984. In order to find the standard deviation, I take the square root of that, and I get 1.449. or 1.45, depending on how many standard deviations or how many decimal places you want to go to. Okay. Now, another way we can do this in the calculator is using the one variable statistics. And so you have to do this kind of in an interesting way. So I just cleared out that list by just going up and pressing clear enter, because it was for another problem from the review, from the homework. So this distribution, the number of homes sold per week is 0 to 5 homes sold per week. That is your X value. Now, if we were to just do one variable statistics on L1, what it thinks is that there is 1, 0, 1, 1, 1, 2, 3, 4, 5, and that's your distribution. And that's not true. We have a probability distribution here, and so that's not going to find you the answer correctly. Instead, in list 2, you need to put the probability distribution so that you can then tell the calculator in that programming, hey, I have a weighted distribution here. If you want to think about this in terms of like 100, technically we have 15 zeros. We have 24 ones. And so you could go into list 1 and do 0 15 times, and then do 1 24 times, and then do 2 29 times. And you could do that and you'd have 100 digits, and that would give you the same answer. Or you can use this frequency probability distribution like so. And so if you go back under stat and calculate, you still want to do the variable statistics on L1, but then when you press comma and then L2, so again, I'm using the list functions down here. Okay, so second L1, comma second L2, that says like L1 is where my X variable is, but L2 is my weighted frequency. And you can see that you get exactly the same answers that we did by doing this the long way. And so that's just one way to check the long way and make sure that you have all the right answers when you're working on these problems. All right, another question that we need to make sure that we go over in chapter 5. I made a copy of these in like little halvesy pages to try to save paper here. This should be okay. We'll see. Okay, is number 15 here. Okay, so on number 15, 60% of people believe that community service should be required to graduate. And then we have a random sample of size 12. So this is my N. And I don't have like a secondary group here. I just want to know in this sample of size 12. And so let's talk really quickly about if I have these 12 people. Okay, in this sample of size 12, I want to know what's the probability exactly 8 of them believe the community service should be required to graduate. So if I want to think about like exactly 8 would be 3, 4, 5, 6, 7, 8. So if each person was independent, we think about finding these probabilities independently, then this would be 0.6, 0.6, and then not would be 0.4, 0.4, So I'm going to calculate this by doing 0.6 to the 8th, because it's 0.6 times 0.6 times 0.6, 8 times. And then I'm also going to multiply by 40% 4 times. So I'm going to write that as 0.4 to the 4th. Now that ordering assumes that the first 8 say yes and the next 4 say no, which we know that that's not necessarily the only combination that could happen if I have 12 people and 8 of them are saying yes. It could be that it's not this one, but it's that one. And so there's all these different combinations. And so you find the number of combinations by doing that 12 choose 8. And so if we do that here, 12 choose 8, there's 495 different combinations that we could have 8 people say yes and 4 people say no. So I'm going to take that 495, I'm going to multiply that by 0.6 to the 8th, and then multiply that by 0.4 to the 4, and that finds me 0.2128, sorry. The other way that you could do this is under the distributions key, which is here with variables, okay? And you could do what's called a normal PDF because we're just looking at 1 point. Okay, so what you're going to do is you're going to put in N, and then you're going to put in P, and then you're going to put in your X value, which in this case is 8. Okay, and it finds the exact same probability that we did. It's a programming that already knows this formula for you. The other thing that you can do with this formula is if you don't put an X value, so just 12 and 0.6, it actually will give you the entire distribution, so starting at 0. So if you needed to know, I actually think it's down here on part B, okay? X is the number in the sample who agree. So the X values could be 0, 1, 2, 3, 4, 5, all the way to 12, okay? And we want to do a probability distribution here. Well, it gives you the entire distribution here. So this would be if x equals 6. This e to the negative 5th says move the decimal to the left 5 times. So that's going to be pretty close to 0 right there. If I press the over button, okay, I get 1. Again, that's pretty close to 0 because it would be 0.0003. So I'm going to leave it there. All right, what about 2? Okay, 2 is 0.002. 3 is 0.0124. 4 is 0.042. 5 is 0.101, so on and so forth. And then you can go all the way to the end. Okay, like we would keep going and doing all of this. I'm just kind of running out of room and just giving you guys some examples to help you review for your test. Okay, so it looks like 12 is 0.00212. Okay, 217. Okay, so you can get the entire distribution if you don't put an x value. But let's just say, just for one more example here, I do binomialpedia 12.6 comma 5. You'll see it gives you the value here. Okay, so binomial PDF, you do n, p, and then x. And no x gives you the entire distribution, okay? If I want to know at least 6, okay, and I'm not going to write all this out because we really don't have a lot of room here, but this is just some examples, okay? So at least 6 would be the probability that x is greater than or equal to 6. Well, that would be, if you look at your distribution table here, 6 and 7 and 8 and 9 and 10 and 11, 12, all the way up to the end here, okay? So you'd have all of these calculations, but each time you'd have 6 here, then you'd have 7 here, then you'd have 8, 9, 10, all the way up till 12, okay? Less than 4 would be the same as x less than or equal to 3, because this is a discrete distribution. So if it's less than, you don't include that value. And so we're going to look at our table here. Okay. Now, another thing that you could do is what's called a binomial CDF, okay, to do like an interval in your calculator here. Now, binomial CDF for the 83 and the 84 always goes from 0 to that value. And so what that means is, like, if I wanted to do 3 here for part C, okay, then I could find that, and that adds all of those up for you. So like this is what you'd find in the book table, okay? Like these would be in the book table there, and then the calculator does it for you. But again, since it does like the other side, if you want greater than or equal to 6, what you're actually gonna put in the calculator is to go up to 5, okay? So that would get you up to 5, and then if you do 1 minus that, then you'd get the other side of the distribution, and so you'd get your answer there, okay? Because in our table, if I want 6 or more, so like 6 or more here, right, up to 12, the opposite of that would go to 0 to 5, and the calculator on the CDF function, so binomial CDF, NPX, and this always goes from 0 to the x value. So if you want the greater than, then you need to subtract from 1. Okay. If we need to find the mean, you could do this the long way, like we just did on that first question, but also remember that you can find the mean by doing n times p. So that would be like 12 times 0.6. So that would be 7.2. Okay, and standard deviation is square root of NPQ. Okay, so square root of n times p times, and then q is like the other part of that probability, or 1 minus p. Okay, so standard deviation of 1.6 7. All right, 16 gets into a hypergeometric formula here. So we have 12 nominations for 4 awards, and 8 of the 12 nominees are female. So again, big N here is 12. Okay, and what we're looking for is we're going to be choosing randomly from the 12 4 people to get awards. So this is going to be like our little n. We have 2 n's here. Okay, and we want to know what are these probabilities within this little n that I'm looking for. The other piece of information that they give us is that there are 8 females, which means that there are 4 males, okay, to make up that 12. What that 8 gives me then is my R value, or my rate of the female proportion inside that 12. And just one more thing, our hypergeometric formula, okay, is the following. So I'm going to write it down here. P of x is R choose x times n minus r choose little n minus x all over n choose little n. And so every single one of these denominators, no matter which question you're doing, is always the total number of ways out of the 12 you could choose 4 people. That's always going to be our denominator because that's our total here. Okay, out of the 12, how many ways could we choose 4 people? The numerator is where we're splitting into males and females. So if I want 3 of the 4 winners to be female, and I want to find that probability of that happening, well, then what that means is 3 females and 1 male get chosen out of this 4, right? Well, if there's 8 females, then I want to know how many ways of the 8 females can I choose 3, which is where this R choose X comes from. 8 choose 3. Out of these 8 females, choose 3 of them. I need to now look at what's left over. Out of the 4 males, choose 1. That's where n minus r, 12 minus 8 gives me 4. 4, choose 1. You then just plug this into your calculator and go from there. So 1 of 4 are female, so 8 females choose 1. 4 males choose 3. At most 1 female. So at most 1 means what's the probability that x is less than or equal to 1? Well, you're already going to know the probability of 1 from part B. Okay, and so I need to figure out the probability of 0 and then add those together on this one. So 8 choose 0, 4 choose 4 out of the total. That's going to give me the probability of getting 0. And so then I'm going to do the probability x is 0 plus the probability x is 1 to get my answer here on part C. All right, the last example from chapter 5 to go over in our review video here is Poisson, okay? And so what happens with a Poisson distribution is all you know is an average over a time frame. So in this one, it was talking about red light cameras, and it said in one day, the red light camera on average gets 10 drivers. Okay, they're caught by this system. And it wants to know what's the probability, well, on any day that 14 are caught, or at most 7, so on and so forth, and so on and so forth. And so the Poisson distribution is the probability of x is lambda to the x e to the negative lambda all over x factorial, where lambda is your average. Okay, and so in this case, that's going to be 10. Now, another thing I want to talk about is this factorial. So if I get like 4 factorial, this operation tells me to multiply 4 times 3 times 2 times 1. Okay, so it goes through and talks about all the different denominators essentially that you could have for that distribution. So here in part A, if 14 get caught, so that's probability x equals 14. Okay, well that's going to be 10 to the 14th times e to the negative 10th all over 14 factorial. You would then just plug those values into your calculator after doing that work here. Now, the factorial button is under math, okay, under math, and then you go over to probability, and it's right there under your combinations button, okay? So that's where it is there. On your Inspire, if you're an Inspire user, you can use like the actual exclamation key right here. So like 4 factorial, and it will do that for you, okay? And that's down here where the little exclamation mark is, okay? So that's just so you know how to do that. Now, at most 7, again, is that like probability x is less than or equal to 7. So what that means is we would have actually 8 different calculations here because you'd have to include 0. So you'd have 0, 1, 2, 3, 4, 5, 6, and 7. Add them all up. Here, probability between 13 and 18, you would do this exact same calculation for 13. Here's 14, 15, 16, 17, and 18. Add them all up, okay? If X is the number of people caught on any weekday and you need to figure out the distribution here, don't forget 0 is a possibility. It's probably very unlikely. And you would keep going. Now, the thing is, technically, this would approach infinity because it could, in theory. But we're really just going to stop this distribution once you get to that probability of being about 0, so that you can look at like, okay, that's not really part of the distribution because it's not really going to happen. But let's just look here, especially if you have this older system. So you would need to do parentheses here or just keep it as numerator denominator, which is probably what I would do. So I would do like numerator, enter, denominator, enter, and then divide. E, if you don't know where that is, second natural log, okay? And you need to use it as the E function here. So that's my numerator, holy schmokers, 14 factorial, okay? And so I have 4, 5, 3, 9, 9, 9, 2, 9, 6, 7 divided by, and then I don't know if you guys know this little trick. Instead of trying to enter that, you can just do like second answer and it will do whatever is that one right there. Okay, second answer. And that's our probability right there, 0.05. Just for 14, okay? And you would do that exact same setup for all the problems on this page. It just depends on what type of question you're being asked. If it's just one or if it's multiple, then you have to make sure you do this for all the pieces in the question that it's asking for, okay? I hope you found that helpful.